Hello everyone, hey students, hey parents, this is Algebra Made Simple. I'm your host Chris Morse. Today we're going to talk about another process for factoring a quadratic trinomial. This is a big idea, a big component of any Algebra 1 or Algebra 2 curriculum. You're definitely going to have to do this throughout the course of the year, even in order to do other skills such as simplifying rational expressions. Factoring is a huge content area that we need to cover. So if you watch my other video, I suggest you go back to it where it said factoring quadratic trinomials when a is equal to 1. Well, today we're going to look at a slightly more complicated method that has given a lot of kids trouble over the years. It's called factoring when the a is greater than 1. So what am I talking about? Let me go ahead and bring it on screen, and then you guys can see the example of which I'm referring to. Okay, so right here you see an example. This is a trinomial. We know this because there are 1, 2, 3 terms. All right, that's what makes it a trinomial. The prefix tri meaning 3. Nomial, that's just kind of another word for terms. How many terms are there? All right, so when I say a is more than 1 or greater than 1, what I'm saying is the leading coefficient. We always, if you ever did the quadratic formula or maybe just solve for axis of symmetry, you're used to the the variables a, b, and c to refer to the coefficients in a polynomial. All right, so a is that first coefficient, the leading one is what we call that in algebra. And whenever that is, when it's visible, to be honest with you, if you see a 2x squared, a 3x squared like this one, maybe a 15x squared, it can be anything. And it's not just simply the variable to the power of 2 or n squared, p squared, something like that. You have to use another factoring method, and we're going to go over that today. Okay, so you may have heard this from your teacher, but it could be a little bit of a cause of confusion. A lot of times they call this the AC method, all right, and that doesn't stand for air conditioning or AC Slater, all right. They call it the AC method. You'll find that with other YouTube videos that are out there online. So here's how it is, okay. As a reminder, when you set up this process of factoring, this setup can be helpful where you'll sometimes, I'm going to do it this way, where you have like a big X. I want you to draw a big X if you're doing this along with me, okay? And just remember that the A, B, and C refer to that first coefficient, so we'll call the 3A the middle coefficient, so that 11 right there would be the B, and then the C would be the 6. Keep in mind I did not say 11x is the B or 3x squared is the A. It's just the coefficient. So it's just this part here, the 3, the 11, and the 6. So when you see AC over here in the corner, that is the product of the A times the C. In this case, it's the multiplication of 3 times the 6, the A times the C. When you see letters side by side, you have to assume they're being multiplied. Well, 3 times 6 is equal to 18. So we're going to put 18 right there, kind of at the bottom. That's our AC. And the B is what goes at the bottom of this X. And the B, you can clearly see, is 11. You don't have to do any multiplication. It just is what it is. And so like you've probably seen in the past, when you're doing the other method, what we're going to try to do is we're going to try to look for 2 numbers, and we're going to put them on the ends. 2 numbers in this case that multiply to our AC. That would be the 18, that at the same time, if you were to add those numbers, would equal the middle number, the 11 in this case. So 2 numbers that multiply to 18, but if you were to add them, would equal the 11, equal the B. So you have to give it some thought, but first thing that comes to mind for me is the product of 2 times 9. 2 times 9 is equal to 18, but if I were to add 2 plus 9, I would also get 11, so that's my winning combination. I tell kids to go ahead and circle those so they stand out, kind of pop out at you, all right? So here's the part that might be a little weird the first time you see it, but it's not really that bad. Once you find those winning numbers, 2 and 9 in this case, they multiplied to 18, they added to 11, now you're going to transpose, or you're going to insert 2 and 9 into the original polynomial, but you have to do it a certain way. So here's what I'm going to do. Go ahead and rewrite the polynomial. It was 3x squared. That first term we're going to keep exactly the same, okay? 3x squared does not change. What will change is this 11x. Instead of saying 11x like we originally had, we're going to change 11x, break it into components, and we're going to take the 2 and the 9 that we just got over here, okay? And we're going to put that instead, or in the place of the 11. Why are we doing that? Well, a couple reasons, but for starters, 2 plus 9 does equal 11. It's not like you're really changing things. They are equivalent, okay? So in math and algebra especially, you can rewrite things pretty much as you want to, as long as what you're doing is still equivalent, okay? So since 2 plus 9 is another way of saying 11, we're going to go ahead and change it from saying 11 to 2 plus 9. So what we accomplished is we've turned this from being a trinomial, where there are 3 terms, and now you'll see what's called a 4-term polynomial. I see 4 terms, 3x squared, 2x, 9x, and 6, okay? Now, if you're familiar from your factoring processes that hopefully you've learned in class, I'm going to just talk to you for a second. You hopefully have learned that when there are 4 terms, you're supposed to factor by a certain method, okay? I'm going to give y'all a second to see if y'all can remember what method that is. Did someone say grouping? You're right. Way to go, invisible student. Grouping is the method that we use to factor when there are 4 terms. You only group when there are 4 terms. So I'm going back to the screen at this point, and I want to show you something. Now that we changed this from a 3-term polynomial to a 4-term polynomial, we are going to do that process. We're going to use grouping to finish factoring this. So if you know your grouping method, this shouldn't be too difficult. If you haven't, pay attention. Okay, what does grouping method mean? It basically means you break up the 4 terms into 2 sets of 2 terms and you factor by GCF. Okay, so we're going to look at this first parenthesis to start. We're not even going to look at 9x plus 6, okay? So 3x squared plus 2x. What is the GCF between those 2 terms? What's the greatest common factor, in other words, that both 3x squared and 2x have in common? Give it some thought. If you said x, you are correct. The only thing they have in common is they each have at least one x. The 3 and the 2 don't really share anything in common. So you can just have a variable as your GCF, and that's what it is, okay? So once we found out that x is the GCF, we're going to then divide each of these terms by the GCF of x. So 3x squared divided by x, you basically just subtract the x. You had 2 x's, now you take away the x. That leaves you with just 3x, okay? And then we do the same thing with 2x. 2x divided by the x. In other words, the x's cancel out. It's going to leave me with just 2. So I'm going to say plus 2. Okay? So we are kind of finished with the left side of this so far, all right? GCF was x. You got 3x plus 2. Now we're going to do the same thing, same process, I should say, for the second parenthesis. What is the GCF between 9x and 6? What do they have in common? The greatest thing that they have in common. If you said 3, you are correct. So when it comes to this set, 3 is the greatest common factor, so we're going to do 3 parentheses, and we're going to divide each by 3. 9x divided by 3 is 3x, and 6 divided by 3 is positive 2, so we're going to say plus 2. Now, you hopefully are noticing something at this point, and I'm going to go ahead and say this. At this point, you should see that you have the exact same answers inside the parentheses here, 3x plus 2 and 3x plus 2. Let me be especially clear. If you are doing the process correctly to this point, you've divided everything correctly, you haven't made any mistakes, you should get the exact same binomials at this stage of the process, okay? That's called a common binomial factor. I'm going to say it again, a common binomial factor. It's almost like there's a new greatest common factor in town, but it's a binomial that's in common to both sides, not just a monomial like you're used to, okay? It's called a common binomial factor. So now that you made it this far and you see the exact same thing, 3x plus 2, 3x plus 2 in each parenthesis, that's a sign that you're on your way and you're almost home, okay? You're doing it great. If you get 2 different things, you need to go back to the drawing board, start over. You probably made a mistake somewhere along the way. So when we have those common binomial factors, we simply identify that and we just write it one more time underneath. So 3x plus 2 is my new GCF. It's a binomial GCF, but I just write it one time. And then I take the GCFs that I had here originally, the x that we had in this set and the 3 in this set, and we're going to put them in the other parenthesis. So the x plus 3 goes into the other parenthesis, and we are, it's ugly 3, but that's it, and we are finished. So the factorization of this trinomial is 3x plus 2 and x plus 3. This is the AC method for factoring a quadratic trinomial when the a is greater than 1. So go back and watch some videos on grouping method if you need to, and rewind this, watch it as many times as necessary till you get the hang of it and get the practice in, okay? So that's it. I just want to make a short video to address this one because this is probably one of the most misunderstood, confusing types of factoring problems that my students come to me for. So I wanted to just put a video out there. Hopefully that gives you some clarity where there was some confusion. As always, keep it simple. I'll catch you on the next one.